So go ahead and open your Carnegie book to page 70. What we're going to be doing is exploring the prime factorization and finding the greatest common factors of numbers. So it says problem number 1, harvest day, on page 70, and the problem states, Pat is creating thank you fruit baskets for the adults who will volunteer at Saturday's harvest day event. She wants to make sure each basket contains an equal quantity of each type of fruit. She has 24 bananas, 12 apples, and 18 oranges. I think one of the key words in this problem is an equal quantity of each type of fruit. So she doesn't want to have different amounts of fruit in different baskets. Each basket should have the same amount of each fruit. So when we see this type of question, my mind immediately goes into factors. So the first part A says, how many different fruit baskets can she make so that each one has an equal number of each type of fruit, So what we know is that we have 24 bananas, right, 24B. We have 12 apples and 18 oranges. Now, there are a number of different type of baskets that we can make. The way that we find that is by finding what are the factors of 24, what are the factors of 12, and what are the factors of 18, and which number do they all have in common. Because again, since we are dividing out the fruits into different baskets and we want equal ones, we need to find that common factor between each number. So, first thing is we need to break up and make a rainbow for 24. So, I know that 1 and 24 are factors, 2 and 12, 3 and 8, 4 and 6, and then 5 is in between, but 5 is not a factor of 24, so I stop there, and I'm going to go ahead and complete my rainbow, okay? Then I move on and I do 12. I know that 1 and 12 are factors, 2 and 6, 3 and 4, and the fact that 3 and 4 are next to each other makes us know that we can stop right there because they're going to connect. And last but not least, we have 18, 1 and 18, 2 and 9, and then 3 and 6, and we can stop it right there. I'm going to connect my rainbow, and boom, we've created 3 rainbows. Now, what are the factors that they have in common? Well, I notice that they have 1 in common, they have 2, 3, they don't have 4 because 18 does not have 4, and then I also notice that they have 6 in common, okay? That's the only factors that I notice that they all share. So she could make 1, 2, 3, 4, and 6 baskets and have an equal number of each fruit, okay? So what we did here is we found common factors. But the vocab word that we work with is greatest common factors. So out of these numbers, part B, what is the greatest number of fruit baskets that she can assemble so that there is an equal quantity of each type of fruit? The answer is 6. Because again, the greatest number, she wants to be able to make as many baskets as possible. So she's going to go with her greatest common factor, which is 6. Okay? Now, let's move on to part C. And let me clear all this out. So it says, if she makes, so we knew we had 24 bananas, let me just rewrite it, 24 bananas, 12 apples, and 18 oranges, right? And we found that she could make 6 baskets. So if I were to make the 6 baskets right here, this question says, how many bananas, apples, and oranges will be in each fruit basket if Pat decides to make the greatest, which we already determined is 6. So if we have 24 bananas, and we need to divide it out amongst 6 baskets, what would we do then? We would divide it out. So 24 divided by 6 gives us 4. Each basket would have 4 bananas. Apples, same process. We have 12 apples divided by 6, and that gives us 2 apples in each basket. And lastly, oranges. We have 18 oranges divided by 6 equals 3, okay? So when they say they want an equal amount, they don't mean they want 4 bananas, apples, and oranges in each, but they want to make sure that every basket will have the same amount. Every basket will have 4 bananas. Every basket will have 2 apples, and every basket will have 3 oranges. And on top of that, there will be no extra fruit left over. Every piece of fruit will be used. So the first thing is finding the factors that they have in common. From there, picking the one that is the greatest, and then doing the division to figure out how many pieces will go into each one, okay? What I want you to do now is to stop the video and attempt to do page 71 with Michelle, who's organizing now a scavenger hunt. So do problem 2, A, B, and C, which is very similar to what we just did. You will have 10 minutes to complete that problem. Once you are done with that, go ahead and flip it over to page 72 and watch the next video on how to do problems 3, 4, 5, and 6.